Good morning everyone, we are come from Group F. Our title is 3.2 Kepler Law. Integration of history. Johannes Kepler, an assistant to astronomist Tycho Brahe. His strong determination motivated him to study broad astronomical data. Finally, he succeeded in formulating three laws that describe the movement of planets around the Sun. Kepler's first, second, and third law. Kepler's first law is all planets move in elliptical orbit with the Sun at one focus. Law of orbit. Planets in the solar system have elliptical shaped orbit. Figures show that the Sun always stays on focus of the ellipse. Major axis is longer than minor axis. Most of the planets have major axis and minor axis almost the same length and same shape of the elliptical orbit of the planet in the solar system is almost round. Planets can be assumed to make circular motion around the Sun. The radius of orbit is the average value of the distance between the planet and the Sun. Kepler's second law. A line that connects a planet to the Sun sweeps out equal area in equal time. Law of area. A planet takes the same amount of time to move from A to B and from C to D. The area FFB is the same as the area CFD. Distance AB is longer than distance CD. This means the planet is moving a high linear speed from A to B than from C to D. Kepler's third law. The square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. Law of period. A planet which orbits with a larger radius has a longer orbital period. Therefore, planets which are further from the Sun take a long time to complete one orbit around the Sun. For example, Earth takes 365 days to make one complete orbit, while Neptune takes 164.8 years. In mathematically, T squared proportion with the R cube. T is orbital period of a planet. R is radius of orbit. Solving problem using Kepler's third law formula. Kepler's third law, that is T squared proportion with R cube, can be formulated by equating centripetal force, gravitational force. For the formula, centrifugal force is F equals mv squared over R. M is mass of a planet. V is linear speed of planet. R is radius of orbit. Gravitational force formula is F equals G capital M over R squared. G is gravitational, capital M is mass of Sun. V equals 2 pi R over T is formula for linear speed of planet. T is orbital period. As such, the relationship between orbital period of planet T and radius of its orbit R is T squared equals 4 pi square R cubed over Gm. So T squared equals Kr cubed when the constant K equals 4 pi square over Gm.
Kepler's third law can be formulated using Newton's universal law of gravitation and concept of cellular motion. Planets make cellular motion around the Sun. The centripetal force is the same as the gravitational force between the Sun and the planet. Assuming that the orbit of the planet around the Sun is cellular, we can derive the relationship between the orbital period of the planet and the radius of the orbit as in Kepler's third law. Gravitational force acting on planet F equals to Gmn divided R squared. Centripetal force F equals to mv squared divided R squared. Therefore, centripetal force equals to gravitational force. mv squared divided R equals to Gma divided R squared. V squared equals to Gm divided R. Linear speed of the planet V equals to distance traveled in one complete orbit divided orbit period equals to 2 pi R divided T. Substitute 2 into 1. 2 pi R divided T squared equals to Gn divided R. T squared equals to 4 pi squared divided Gm R squared. Compare two planets. For planet 1, T1 equals to 4 pi square divide gm r. For planet 2, T2 equals to 4 pi square divide gm r. 1 divide 2 gives that T1 divide T2 equals to R1 divide R2. The equation T2 divide T2 equals to R3 divide R3 can be used to calculate the orbit period T or radius of orbit R. Example figure shows that the planet Earth and Mars orbiting the Sun. The radius of the orbit of planet Mars can be determined by comparing the orbit of Mars with the orbit of Earth. What information is needed to determine the radius of the orbit of Mars? Radius of the orbit of Earth, orbital period of the Earth, and orbital period of Mars. The radius of the orbit of Earth is 1.50 times 1011 m. Orbital period of the Earth and Mars is 1.00 years and 1.88 years respectively. Calculate the radius of the orbit of Mars. Solution is step 1. List the given information in symbol. Step 2. Identify and write down the formula used. Step 3. Substitute numerical values into formula and perform the calculations.